ideas, okay? I'm going to give you definitions and examples. It's going to be really, really important that you're able to make those connections. So if I were to give you a lab setup idea or like data, and I asked you, what is this? Is it an observation, an inference? You can tell me. Is it qualitative? Is it quantitative? You can tell me. If I gave you the data and asked you if it was precise or accurate, you could tell me. Now I have to be 100% honest with you. The precision and accuracy is usually the one that gets us, okay? Because we really, really, really use those terms and we lump them together often, right? Okay, so we're gonna go through this today, and then after that, we are going to write up our fish inquiry lab, and we'll talk about that. So you're gonna propose your lab. Those of you who are face-to-face will actually do the lab. Those who are virtual will watch me do a lab and then analyze it. Okay, so observations. Oh, here we go. Thank you. 8:51. All right, so observations. Observations is something that you observe, you gather using one of your senses, right? One of your 5 senses. These are your facts. Without a shadow of a doubt, this happened, this happened. I need you to understand, guys, that oftentimes we infer and we consider it an observation. We have a lot of inferences in our day-to-day lives, and then we consider them observations. So it's going to be actually kind of a challenge to cut away all those inferences and solely observe, okay? So again, observations are our facts. So there is a television in the room. There is no TV in this room. So I'm going to say I need to change that, but I can't change my nearby. So there is a large Promethean board in the front of the room. Observation, you see it, you know it's there. There is no question. Guys, as you take notes, you do not have to write every word. If you want to write every word, by all means. Have we talked about this before? Okay, so just remember that. You're welcome to, but you do not have to. Do understand, though, I will expect you to know what an observation is. If I were to give you an example and ask you, I would expect you to be able to pick the observation within, or that it was an observation. So observations are your facts. Inferences are more of what we assume, right? These are our educated or logical guess. There's a logical interpretation based upon prior knowledge and experience. This is based upon observations, based upon what we have experienced in the past. So if you were to enter the room, you would most likely assume or infer that the individual at the front of the classroom is the teacher. Is that always the case? No, sometimes you might be doing a presentation, or it might be the principal or a guidance counselor, right? But that would be your inference. If the grass is wet in the front lawn at the school, you would infer that it rained overnight. Does that mean that it rained overnight? No, a dog could have peed, or the sprinkler could have come on, right? Inferences. Now, in a lab experiment, there is a place for inferences, but it is not as we're gathering data, okay? So when we do our labs, it's going to be really, really important that we record observations and not inferences. When we write our conclusion, that's where you will make your connections. That's where you'll make those little jumps to those inferences, okay? So really, really, really important. Okay, so that's just what we said. So in lab experiments, observations, not inferences. And the conclusion is where we'll make an inference. All right, look at this picture. Look really good. Just a reminder, because I'm supposed to say it 3 times, I am recording this class today. Just to let you know, if you didn't hear me the first time, I'll have to say it 3 times. I am recording this class today. And one more time, I am recording this class today. All right, did you see the picture? You got it? All right, I have questions. Are there any, on your page, on your screen, are there any cars on the side of the road? I am very bad at observations. All right, and then the next question is, what was the color of the truck? So real quick, were there any cars on the side of the road? Yes. What was the color of the truck? Blue, light blue specifically, but if I gave you too many specifics, you would know the answer, right? Okay, you ready? Are there any minivans? Gets a little tougher. You are right. So were there any minivans? There was. Yeah, hold on, let's go back. Do you see it? Right next to the telephone pole? You can totally tell it's a minivan. You don't think so? All right, this one's even harder. What is the blue sign? What did the blue sign say? I can't read it either. But it's there, and most people actually can. So your answer for what the blue sign said, is that your observation? Did you really see it, or now we're making inferences? Are you guessing what you think it might have been? Because obviously you can kind of whittle down what the sign may be because it's a blue sign on a telephone pole, right? It's a yard sale. Did you get it? Very good. Yeah, I wouldn't know either. All right, so it's our yard sale sign. And now this one's way easy. The first one's way almost too easy. The easiest one so far. What was the speed limit? And then the second question says, are there any pedestrians? What's a pedestrian? Let's just a person, like a person walking down the road or the side of the street. Very good. So all right, so what was the speed limit? 35, you got it. Any people? No. All right, so let's talk about quantitative versus qualitative. Now, I was just messing around with the Nearpod features. This is a slideshow, so you're actually gonna have to click through it for these three. But you should be fairly familiar with quantitative versus qualitative, yes? Or at least you know what the terms are. If you know you recognize the terms, but you don't remember what they stand for, please, please, please make a note of this. I will ask you in labs, the data you collected, was it qualitative or quantitative? Or this is the lab, tell me the pieces, okay? So a quantitative observation, because it has an N in it, it deals with numbers. These are our quantities, okay? So this is a measure of what we observe. Quantitative, excuse me, I won't say quality. Quantity, so these are our numbers. So the flower has 7 petals. Miss Shoemake has 2 eyes. Now, once you've got this, you can click through it on your own. If you're still writing, you're fine. The next one's going to be qualitative, okay? And our qualitative will be our qualities. These are descriptive. These are adjectives. Describes what we observe. So the flower has white petals. Miss Shoemake has blue eyes. So again, I know I'm not asking you to be speed writers. Just know that you can just click through these as you are ready. For some notes that we're going to do later on this week when we start talking about metrics and measurements, I did do fill in the blank notes just so that maybe we aren't so overwhelmed with writing, especially when we start talking about significant figures, because it's such a different idea than what we're used to. So if you're virtual, I will post those hard copies online and you can print them, or if you want to swing by the school and pick them up, I can leave them at the front. You just have to tell me. If you're face-to-face, obviously you're here, so I will hand you a copy when we get to that day, okay? But again, if you're virtual, I'll post them. You don't have to use them. I really don't care. I just tried to make it to where it's easier for you and you're not having to try to jot so much down. So if we click to the third slide here, again, if you're still learning, you are fine. I'm not rushing you. But the third slide is just some examples. So quantitative observation would be a bunch of beautiful, round, smooth glass marbles, whereas our quantitative would be 5 marbles at 1.5 centimeters diameter each. Again, descriptive versus numeric. Now, if you're still writing, you are totally fine. I am going to pause this here. But the next question, the next slide is a question for you. So I'm going to let some go ahead and start working on that question. And if you're still writing, there's my qualitative up there. Okay, so let's look at this image. What is an observation and what is an inference that you could make from this? Now, guys, listen. Or did I say one or two? So I just want one observation and one inference, and you can literally put O equals I equals. You don't have to write it all like out, okay? So what is one observation and one inference you can make from this picture? All right, you ready? Okay, so there's obviously a ton of different answers you could give. This one says there's a roller coaster, that's the observation, and the inference is that it's a theme park. Very good. Do we know for sure it's a theme park? No, that's our inference, so perfect. Very good. So lots, and again, there's a lots and lots of different ways that you could say this. Yeah, perfect. All right, so let's look at this picture. I want you to give me 2 quantitative and 2 qualitative observations. Now, you don't have to write out qualitative and quantitative if you don't want to. Just make sure you bullet them. We can obviously pick, hopefully, the difference. So one more time, guys, I am recording this classroom. Just to throw that out there if we missed it. All right, so here we go. Qualitative is that the basketball is brown, the soccer ball is black and white, and quantitative would be that there's 5 different types of balls and 1 baseball bat. Perfect. Obviously, there's a lot of different answers you can give, right? So we want to make sure our quantitative has to be numeric and our qualitative is descriptive. Okay. Now, accuracy and precision. Again, guys, this is definitely, out of everything we've done so far, probably the newest maybe or thing that we need to make sure we catch. Okay, so accuracy is how close a measured value is to the actual or true value, and precision is how close the measured values are to each other. Again, accuracy is how close a measured value is to the actual or true value. Precision is how close the measured values are to each other. All right, so real quick, let's talk about this for a second. So let's talk about accuracy. So accuracy is on the bullseye, right? Where you hit, where you're getting exactly the amount or the measurement you expect. So what is boiling point in Celsius for water? Any idea? Come on, guys, what's boiling point? It's super easy when it's Celsius. 100. Yeah, 100 degrees Celsius. So if I were to give you 6 cups of water and ask you to measure the boiling point, and let's say you got 101, 100, 99.9 consistently over and over again, you would then be considered accurate because you're right. You don't have to necessarily be right on the dot, but you're right close to it. Okay. But if you were to get like 99, 98.7, right, then you're not accurate at all. You're pretty far off. Precision is how close your values are to each other. So let's say we measure this boiling point for water and we were not on the dot. We were like 99, 98.9, 99.1. That is not accurate, okay? But because they are lumped together, that would be precise. Does that make sense? So my husband gets me to go golfing with him sometimes. It is not a pretty sight. I would be okay with 9 holes, but once we get to 18, I'm just done by the end, okay? But I'm really, really bad, like really, really, really bad. Really, really, really bad. So to the point that by the time we're getting done, I can pretty much tell you about where in the woods my ball is going to go. Never on the green. That would be way too easy, okay? But it's gonna go to the left every single time. Very low accuracy. Takes me forever to get through a hole of golf, okay? But by the end, I'm pretty precise because it pretty much hits about the same spot every time. Not where it's supposed to. Does that kind of make sense? Okay, so we want to make sure we catch the difference between precision and accuracy. Now, if we were to look at these bullseyes, okay, the one furthest to the left is going to have a low accuracy because it's not on the bullseye itself, but it does have a high precision because they're lumped together. The middle one is one that we actually sometimes struggle with, where it's a high accuracy but a low precision. Guys, this is where like one of your darts may go to the left, to the right, the top, the bottom, still lumped close to that bullseye, right? But they're not quite lumped together. Okay, whereas the last one would have the high accuracy and high precision. Okay, so our example is of soccer. So if you're playing soccer and you always hit the left goal post instead of scoring, then you are not accurate, but you are precise.